Hello everyone. In this video I wanted to go over a few example problems of how to calculate out average velocity. Just a quick reminder of what average velocity is. It's the displacement, change in displacement, divided by the time interval over which that displacement occurs. So the first example that I wanted to do out is if you travel 100 meters at 5 meters per second and then travel 100 meters at 8 meters per second, what is your average velocity? I do have to note here that I am assuming that all motion is in a straight line, so we're not doubling back to end up in the same spot. So we go 100 meters forward, and then we go another 100 meters forward from that. You might be thinking that if I just take the average of the two velocities, which is 6.5, that would get me the correct answer. However, you would be wrong. Your guiding questions when trying to sit there and figure out what is the average velocity an object is traveling at is you need to think, how far do you end up moving overall, and then how long does it end up taking? Those two pieces of information are very, very important to figure out. In this problem, figuring out how far isn't too bad. We travel 100 meters in the first segment, we travel 100 meters in the second segment, so therefore the total displacement ends up being 200 meters. In figuring out the time that it takes, well, time is equal to the distance divided by the speed. So, and we have to kind of treat this at two different parts because we're traveling at different velocities. So 100 meters divided by 5 meters per second means that it would take us 20 seconds to cover that first segment. 100 meters divided by 8 meters per second gives us 12.5 meters per second. Or pardon me, 12.5 seconds for the time. And therefore, the total time that elapses is just 32.5 seconds. So now we know the total time, and we also know the total distance. We're ready to calculate out the average velocity. So the average velocity is just the 200 meters that is traveled divided by the total time, 32.5 seconds, and that gives us 6.2 meters per second. So notice that it's a little bit lower than just the average of the two velocities. But again, just to recap, we found the total distance, or pardon me, the total displacement that we had, and we divided it by the total time, and the time we had to break up into two segments. Alright, a new problem. A person takes a trip driving with a constant speed of 10 kilometers an hour, except for a 30-minute rest stop. If the person's average speed is 10 kilometers an hour, how much time is spent on the trip and how far does that person travel? Once again, I'm assuming straight line motion at the moment, that all of this motion is in one direction. At first, this seems rather challenging, and it seems like I'm not giving you enough information to solve the problem. But first, let me define a few things. Let me say that capital T is the total time. T1 is the time that we spend driving. T2 is the time that we spend stopped. And D is the distance that we end up traveling. So with this, I don't get far away from the idea that the average velocity is the total displacement divided by the total time. But now, once again, the total time is broken up into two segments. T1, which is the time that we spent driving, and T2, which is the time we've spent stopped. And I define that time to be 30 minutes or 0.5 hours. The total distance that is traveled is equal to the time the time that we spend driving, T1, multiplied by the 10 kilometers per hour. I'm hoping it makes sense that during T2, the time that we're stopped, we're not going to add anything to the distance. So therefore, the total distance that we would end up traveling is 10 kilometers an hour multiplied by the time that we're actually driving. Now, at first, this is going to look a little messy, but if you look at the equation and try to comprehend what's going on here, you'll see that there's only one equation and one unknown. Here, 10 kilometers an hour times T1, that is the total distance that we travel. and we divide that by the total time that it takes us to travel, t1 plus the half an hour, and we know that this has to equal 9 kilometers an hour. And this is usually the part that students have a tough time with, is because usually you're calculating out the 9 kilometers an hour, and also this trick of saying that speed multiplied by time is a distance is also a little bit, wait a minute, why are we doing that? But if you look at the equation now, it hopefully makes some sense. I've only got t1, the time we spend driving, in the equation. One equation, one unknown, and I can solve for that. So now it just becomes how good of an algebra, it becomes an algebra problem at this point. So I'm going to drop the kilometers an hour just to make it a little bit neater. I bring the denominator over to this side, multiply both sides by t1 plus half an hour. So I get 9 times t1 plus 4.5, and with that I still have the 10 t1 from the numerator here, still there. But then when I subtract 9 t1 over onto this side, because it's not due to addition, I can do subtraction, I find that t1 equals 4.5 hours, is what it should say. My apologies. And the total time is just t1 plus t2. We already know what t2 is. That's 4.5 hours plus 0.5 hours. So the total time spent traveling is 5 hours. To figure out the total distance, well, we just go back a few slides to grab that equation. The total distance that's traveled is just the velocity with which we travel at 10 kilometers an hour multiplied by the time we spent traveling at that velocity. And the total distance that would be traveled would just be 10 kilometers an hour times 4.5 hours. And that would give us 45 kilometers for the total distance that was traveled. I hope this was useful for a few of your homework problems. Thanks for watching. On the road again. I just can't wait to get on the road again.